3, 2, 1. I might just have stumbled across the best idea ever. I believe that with a motor like this is a DC 12 volt motor, a brushed motor, and we need a controller. This, a PWM controller. This should be able to control the speed of the motor, and so attaching this to a 3D printer with something like this, a shuck and an engraving tool attached to it, we should be able to convert our 3D printer to an engraving tool. Maybe. So here's the idea. We'll take the not so powerful brushed motor, we'll connect it to the PWM controller, connect it to a power supply. The power supply feeds power to the PWM controller and the motor. The PWM controller just makes us able to regulate the RPM of the motor. We might have to try different tool heads to find the most optimal engravability. That's a word. What sparked this idea was something I made a couple of years ago. I remember it being extremely exhausting just mapping out this not so detailed picture. So that's why we are converting a 3D printer to an engraving tool. I'm just going to use the Creality CR10. The acrylic sheets fits pretty much perfectly. It's a popular printer, so statistically that should give me an edge. All we have to do now is design and print some kind of mount for the motor. And so here I have sketched up a quick motor mount, and I actually used the canvas feature, meaning I took a picture of the actual X gantry of well, the hot end attachment plate of the CR10, and I just sketched out the perimeter in which I saw the mount fit on the plate, and well, I then built the cup holder of the motor. This is where the motor goes in, and you can screw it from beneath, so it will be well attached into the cup. And this little hole here is for a fan to be mounted. I'm not completely sure if that's needed, and these two holes are for the original holes on the X gantry plate to be mounted. So those are going in right here and actually attaching the motor mount to the X gantry plates. That doesn't look too bad, eh? The motor is in place, the motor mount feels extremely solid. And then we'll take the PWM controller, connect it with some wires to the motor, and then we'll start printing, engraving.
Oh yeah.
Okay, everything is ready to go. Plugging in the power. I attach the PWM controller to the frame. As we rotate this knob, the motor starts. And that's all there is to it. How about we start off with our favorite character, SpongeBob. Click the image and image trace inside Adobe Illustrator, and then expand, and you're ready to export it as a SVG file. Oh, now you can already see I've done it. I got busted. Going back to Fusion 360, insert SVG, click the plane, click the image, and there we have a Spongy. Yeah, and just like so, SpongeBob is flipping those burgers. We could probably stretch him to 105% scale, go to uniform scaling, and make him 0.1 millimeter thick. We just want the first layer. Regarding the process settings, I've been tuning these. I've been thinking about tuning these. You probably want to decrease the nozzle to 0.2 so you can decrease the extrusion width. I think that's going to be really important. The retraction setting, you want to have the retraction vertical lift activated to 1 millimeter, 1.1 millimeter layer height. Nothing interesting to see. No temperatures needs to be active. Cooling 100%. If we decide to attach the fan, that's going to be activated on the first layer. And go fairly slowly. That's pretty much it. Let's make some magic.
SpongeBob is looking sharp. He's almost perfect. I will explain in just a minute why he is not 100%. But the idea totally worked. And it didn't take more than 30 minutes. Who would have thought it would be so easy to just add a motor to a 3D printer and this would actually make sense. The picture is precisely what I thought it would be. I think the tool went in just far enough. I don't wish it to go in further because that could make the edges much rougher. I don't want it to go in less because that could make the engraving less effective. I think it turned out great in those aspects. The one thing your Swedish boy messed up was the ending sequence, and that's why we have a line going from the print to the very edge. You see, before the print starts, the tool lifts to avoid scratching the surface. I forgot to do the same with the ending sequence.
We need some kind of base, and I think I came up with a pretty good design. It's based on 3 sections. The top one have a slot where the acrylic sheet will be placed. The second one carries the slot where the LED strip will be attached to. And the third one, just a room for cables. And all of these 3 sections will be clamped together with 4 screws in each corner. The top one is going to be black. The middle one is going to be white, and the bottom one is going to be black as well. What I'm really hoping for with this design is that the black parts, the top and the bottom, will block the light, and the middle one, the white, will enlighten the stream of light throughout the middle section. Hopefully that will look really cool. That will be very similar to the design that I made a couple of years ago, but this time I'm gonna 3D print the entire thing, and hopefully it will look good with the LED controller box in the back just like so, and the cables all tucked in together within the design. So that's what we're gonna do next, so let's get printing.
Oh, that trips. This turned out pretty chicken incredible. It was printed in PLA, black, white, black. Even though the LED lights are on, it does not penetrate the white PLA, which that was the idea, that it would be a light of stream going here, so, but it just isn't. So what I'm going to do is print the white portion, the white section, in transparent PLA instead, and hopefully that will work a lot better.
Okay, here we go. Oh, maybe it is all the way down. Why is it so faded? Why is there no light on the upper half? You can probably tell that there is no light from this point. Oh my. Well, that's how the picture should look. I don't know how well that turns out on camera, but this one has a blue edge, this one has a clear edge. The blue edge is blocking a lot of the light, meaning this one works a lot less better to reveal the image than this one. Looks like we have to go to the store. Okay, let's do it. The LED base I think turned out very well. I got the controller attached in the back, so it should be well hidden. And you can clearly see the line of blue. We can change the color to green, to red, blue, and basically everything between. I'll leave it on white for the purpose of showing the pictures, which the first picture is Halloween SpongeBob. Couldn't leave SpongeBob out of the picture, but I have to say my personal favorite would be this one, the interlocking rings, a 3D illusion. I would be very happy having this as a night lamp. So let's put them in the base and see the final result. I just hope you found this video inspiring, and if you think this was a cool idea and would like to make it yourself, I've uploaded the motor mount on Thingiverse. You will have access to it completely for free. I've also made a components list in the description below so you can see what components I used. Let me know in the comments below which one of these two pictures you like the most. My vote is on Halloween SpongeBob. Simon out.